Hello children, welcome to Zero Panic Maths. Okay, now in today's session, let us continue with the remaining problems of the end of chapter exercises in linear polynomials. Okay, in the previous session, we have seen the problems from 1 to 7. There are totally 14 problems are there in this end of chapter exercises. We have seen already the 7 problems in the previous session. So if you have not watched that video, the link is given in the description. You please watch that video before you start watching this. Okay, let us continue with the 8th problem now in today's session. Okay, let us read the problem. It is all based on the linear polynomials, as you might be knowing it. Okay, now this problem also talks about a linear polynomial, but about the temperature of a liquid. Okay, let us read the problem carefully. If the temperature of a liquid can be measured in Kelvin units as x Kelvin. Okay, so this should be read as x Kelvin, and in Fahrenheit as y degree Fahrenheit. Okay, so the relation between the two systems of measurement of temperature is given by the linear equation. Okay, so don't think much about this. There is a liquid, the temperature of which is measured in two different units, and one is in Kelvin, the other is in degree Fahrenheit. Okay, so that temperature, the formula between the conversion between the two measuring units is given by this formula, that is y which is in degree Fahrenheit. Okay, is equal to 9 by 5 x minus 273, and the whole value is added with 32, the plus 32. Okay, now what are the problems? There are two different kinds of answers they need here. First thing is find the temperature of the liquid in Fahrenheit by using this formula, because this is already given. It is a degree Fahrenheit. If the temperature of the liquid is given as 313 Kelvin, 313 Kelvin. Okay, so here you can say, here it is the given as x value. Okay, x value is 313 Kelvin. Okay, you need to just put the value of x into this formula, and the degree Fahrenheit, the liquid, the temperature of the liquid in degree Fahrenheit, you will get easily by this formula. Understood this? Okay, that is what the problem number 1. Now what about problem number 2? Is if the temperature is 158 degree Fahrenheit. Now here y is given, see, as y is degree Fahrenheit. Okay, so here you can say y is equal to 158 degree Fahrenheit. Okay, so we need to find out, then find the temperature in Kelvin. So we need to find out the x value. You understood this? Okay, so first we will find out y directly by using this formula, but for the second one we need the value of x. So let us convert this formula so that we will get the value of x here first, so that we can use it in the second part of this question. Understood this? Okay, now let us, how do I get the value of x by using this formula? Just by transferring all these constant values to the left side and putting keeping only x at the other side. Okay, so now let us first transfer 32 to the right side. What it will be? Okay, now here only, because of the space, I will just convert that here only. You can write it step by step in your book. Okay, okay, now what I will do here is 9 by 5 and into bracket x minus 9 by 5 into bracket x minus 273. I will write the right side part to the left, and directly taking 32 to the left side, it will remain with y minus 32. Okay, this is the second step. Now finally, okay, next step, what we will do is 5 I will take this side, and 9 also I will take this side. It means 9 by 5, if I take it to that side, it will become 5 by 9. Okay, so the next step is it will remain with 273 in the left side. See, I'm keeping only x minus 273 this side, and taking this 9 by 5 to that side, it will make it as 5 by 9 and into bracket y minus 32. Correct? Y minus 32. Understood this? Okay, now look at this step. Now finally, what is the value of x? I can take this minus 273 to that side. It will give me the formula for x as 5 by 9, 5 by 9 uh, into bracket y minus 32 plus 273 plus 273. Okay, now don't get confused here. I'll just mark this as like this. Okay, so let me write this 273 correctly. It is plus 273. You have to write it in native way. Okay, so therefore y is equal to, let us substitute 9 by 5 here. I'm substituting 313 in place of x. Okay, so it is 313 minus 273, right, plus 32, plus 32. Okay, now what is the value next? It is 9 by 5 multiplied by the bracket value. Okay, it is 40 and plus 32. Okay, so it is 5 ones are 5 eights are, it is 9 eights are 72. Okay, plus 32. Okay, so it is 70 plus 30, 100 and 104. Therefore y is equal to, it is 104 degree Kelvin. Okay, sorry, degree Fahrenheit. Okay, it is the value of y that you are finding out. So this is the answer for the first problem. Understood this? Okay, now similarly, just substitute the value of y here in place of x formula. Okay, so therefore I can write it as x is equal to, it is 5 by 9, 5 by 9 minus 158, sorry, 158 minus 32. Okay, plus 273, plus 273. Okay, now what is the next step? It is a simple calculation. Okay, multiplied by 158 minus 32, it is 126. Okay, plus 273. Okay, 126, it is 9 ones are 9 ones are 9 and 3 remains, it is 9 fours are 36. Okay, 14 fives are, it is 70. So 70 plus 273, it is 343. So okay, so therefore finally x is equal to 343. What you want is in Kelvin. Okay, 343 Kelvin. Okay, now let us see the next problem, which is also based on the linear polynomial only. Okay, now let us read this problem and then try to understand how can we represent this into a linear polynomial. Okay, okay, now the work done by a body on the application of a constant force. Okay, now this is based on the physics formula of work done. Okay, you might have studied that formula. Work done is equal to force applied multiplied by the distance traveled. Okay, if you apply a force on any object by some value, then what is the distance traveled by the applied force is what is called as work done. Okay, so that is explained in this problem. Try to understand this problem first. Okay, so the work done by a body on the application of a constant force, okay, is the product of constant force. Try to understand the quantities or the values involved in this. Okay, it is the constant force one, constant force and the distance traveled by the body. As I already told, it is the product of constant force and the distance traveled. Okay, we can easily write this in the direction of the force. Express this in the form of a linear equation. They first want us to express this formula in the form of a linear equation in two variables. And what are those two variables? They have already given. One variable is work, which is represented by W, and the another variable is distance. Okay, and draw its graph by taking the constant force as 3 units. Okay, so the force value they have given it as 3 units. We need to draw a graph also based on that. And then finally they have asked one question: what is the work done when the distance traveled is 2 units? Verify it by plotting it on the graph. Now let me write the given formula first. Okay, given is work done. Listen to me this. Okay, work done is equal to, what is the formula that they have told? Work done is product of constant force and distance traveled. So simply it is force multiplied by distance. Force multiplied by distance is what is called as work done. And they have already given work done should be represented by a variable W and distance by D. Okay, now let me represent this force as F and distance as D. Okay, so this is the formula that what we want. Work done is equal to force multiplied by distance. Okay, now what is next is to calculate the work done for a constant force of 3 units and distance traveled is 2 units. Okay, now constant force of 3 units for which we are actually drawing the graph. Okay, so I can just reframe this formula by considering the constant force as 3 units only, because for that only you are going to plot the graph. So considering F is equal to 3, F is equal to 3, the formula will become, this formula will become W is equal to 3D. Correct? So let me consider this formula only and call this as equation 1. So this will be the formula used. 3 times the distance is work done, because we have the constant force as 3 units. Okay. Now let me answer this question first. What is the work done when the distance traveled is 2 units? Okay, so substitute D is equal to 2, that is the work done. Okay, so therefore if D is equal to, if distance traveled D is equal to 2 units, work done W, I can say, then work done W is equal to 3 into 2, that is 6 units. Correct? So this is the answer for the question theoretically. Now we have to verify it by plotting it on the graph also. Okay, so let us plot the graph. I have already plotted the graph with different values here. We have to just point the coordinate points here. Okay, mark the coordinate points. Now as I already told in the previous session also, just to save the time, I have already drawn the line, but you have to first calculate the coordinate points for the given D. What is W? We have to calculate it by this formula. Okay, as I already told, the polynomial is y is equal to ax plus b. As you already know, it is W is equal to 3D. We don't have this B part. Can you observe this? This is a linear equation coinciding with y is equal to ax plus b, linear polynomial formula. Okay, or you can say the standard representation of a linear polynomial. Okay, so D is equal to 0. If you substitute here, W will become 0. That is the first coordinate. Okay, secondly, if D is equal to 1, W will be 3. Okay, just substitute 1 here. If D is equal to -1, the W will be -3. I've substituted different values and calculated this. Okay, so if D is equal to 3, 3 into 3, W is equal to 9. And for this 2, I have already calculated it is 6 units. But here in this, I have not substituted the value of D. D is equal to 2. What is W? I don't have calculated this, but through the graph I have to prove it. Okay, that it will be 6 units, because theoretically we have proved that it is 6 units. Let us see whether in graph also we are going to get 2 is equal to, when you put D is equal to 2, you are going to get W is equal to 6 or not. Okay, let us plot this coordinate points. 0 0, this is the first coordinate point. Okay, it is 0 0. Okay, fine. Next is 1 3. If it is 1, it is 3. See, it is passing through that. It is 1 3. Next is minus 1, minus 3. So if it is minus 1, minus 3, see, it is minus 1, minus 3. Okay. Next is if there is a positive 3, then it is 9. Now here I am considering, don't get confused. I am considering D as X and W as Y. Fine. That's why D are the X coordinates and Y are the W values. Y coordinate values are the W values. Okay. 3 and 9. So if it is 3, it is 9 coordinate here. 3, 9. So let us draw the line. Okay, assume that you have not drawn the line. So after marking the coordinate points 3, 9, 1, 3, 0, 0 and minus 1, minus 3, if we write if you draw the straight line, it will be passing through the origin, obviously. Okay, and also let us find what is the value of y or w when you put x is equal to 2. Okay, now what is x? It is x 2 here, where it is cutting the y-axis or where it is passing through the y-axis, that is at point 6. So if x is equal to 6, y is equal to, sorry, if x is equal to 2, y is equal to 6. Okay, so here graphically also you proved that uh, for d value is equal to 2, w is equal to 6 units. Okay, so that only you will write it from graph also. From graph also, what all we need here is um, if distance traveled, if d is equal to 2, then y is equal to 6 units. Y is equal to 6 units. That is w is equal to 6 units. That is what you have proved it graphically also. So this is also a simple question, but there is a graph involved in it. We need to first calculate it theoretically and then plot it uh, and prove that by graphically also. Understood this? Okay. Okay, now simple question only. Let us move to the next question. So in this problem also, if you see, we have to derive this polynomial p of x theoretically first with the given coordinate points, and then we have to draw the graph and verify our answers. Okay, let us read the problem carefully. The graph of a linear polynomial p of x in general passes through two coordinate points. Those are 1, 5 and 3, 11. Okay, there are three different parts of this question. First is we have to find the polynomial p of x if it passes through 1, 5 and 2, 3, 11. Okay, and then after finding out the polynomial, find the coordinates where the graph of p of x cuts the axis. Okay, both axes. Here they have given it as axis, not particularly for x axis or y axis. And then finally draw the graph and verify our answers. Let us do that. Okay, listen to me carefully now. Now if p of x passes through the points 1, 5 and 3, 11, it means that if x is equal to 1, y is equal to 5. Okay, so let me consider this. Let y is equal to ax plus b. Okay, or we can say we know that it is not we are considering, we know that y is equal to ax plus b is a linear polynomial, okay. And if I consider this y is equal to ax plus b as p of x, okay. And if given is what are the two coordinate points given? Given is if x is equal to 1, y is equal to 5. Okay, if x is equal to 1, listen to me carefully. Okay, if x is equal to 1, then y is equal to 5. What do you mean by this? Just a substitute y is equal to 5 here and x is equal to 1 here. What it will be? It will be a into 1, that is a plus b is equal to 5. Is it not? So therefore I can say a plus b is equal to 5. Okay, this is equation 1. This I have derived it from this coordinate. Y is equal to 5 here and putting x is equal to 1. Understood this? Okay. Carefully do it for the second coordinate also. Okay. Now, and if x is equal to, what is that? 3. If x is equal to 3, then y is equal to, what is y? Y value is 11. So it means that 3, if you substitute here, it is 3a, right? 3a plus b is equal to 11. So I can write it as here only, let me write it. Therefore, 3a plus b is equal to 11 is equation 2. Okay. Now, if I find out the values of a and b by using the equation 1 and 2, I will get the the linear polynomial p of x. See, this is my general format of a linear polynomial. Then if I find out the values of a and b by using these two and substitute that, that will give me a linear polynomial p of x. That's all we are going to do it here. Understood this? Okay. Now let us subtract equation 1 from equation 2, or you can say equation 2 minus equation 1. Equation 2 minus 1. What it will give me? 3a plus b on the left side, 3a plus b, and minus of a plus b. That will be a minus b only. Okay, minus a minus b, and it will be 11 on the right side and 5 on the from the equation 1. Okay, now it will be 3a plus b minus a minus b. The minus is getting multiplied into both the terms of the inside bracket. Okay, so 11 minus 5, that is 6. Okay, now do it. Minus b plus b got cancelled, and 3a minus a is 2a. 2a is equal to 6. Okay, let me write it here. Therefore, 2a is equal to 6. Okay, if 2a is equal to 6, a is equal to 3. A is equal to 3. Okay. Now substitute a is equal to 3 in equation 1 to get the value of b. Simple. Okay. Substitute or you can say from equation 1. From equation 1, keep b left side and take a to that side. It will be b is equal to 5 minus a, and that is 3. 5 minus a. So therefore b is equal to 2. B is equal to 2. Now substitute that b is equal to 2 and a is equal to 3 in this. You are going to get 3x plus 2. Y is equal to 3x plus 2. So therefore, uh, uh, we can say the polynomial, or the required polynomial, the required polynomial p of x, the required polynomial p of x is equal to, it is 3. See, in place of a you are putting 3, so 3x plus b is equal to 2. That is 3x plus 2. Understood this? Okay. Now this is the answer to the first part of this question. The second part of this question will be, find the coordinates where the graph of p of x cuts the axis. Okay. Now suppose if you consider this as y is equal to 3x plus 2. Okay. Now listen to me carefully. In y is actually the polynomial p of x. Okay. Now how do you calculate? In the previous sessions, we have discussed that if you put x is equal to 0, whatever value y you get, that is the point where y axis is cut. If you put y is equal to 0, whatever value of x you get, that is the point where x axis is cut. Understood this? Okay. X is equal to 0, y axis will be cut. Y is equal to 0, x is axis will be cut. Okay. So let us just theoretically find out those coordinate points first, and then finally drawing the graph for 3x plus 2. Y is equal to 3x plus 2. We will draw the graph, and let us verify whether all those points or the points of x coordinate cutting and y coordinate, the intersection of y coordinate and x coordinate, whether you are graphically going to get the same values or not. Okay, let us do that in the next slide. Okay, now this is the graph I have already plotted, but let me first calculate the points where the y-axis and x-axis are cut. Okay, so don't look at the graph now. Let us consider this first. Okay, let y is equal to 3x plus 2 is the polynomial, right? So this is the polynomial that we already have found out. Okay, this is the polynomial. So in place of 3 p of x, I'm taking y. Okay, that's all I'm doing. Okay, now I can say if x is equal to 0, if I put x is equal to 0 here, if x is equal to 0, then what is y? What is y here? This term will become 0 and y is equal to 2. Y is equal to 2. So the point 0 2, see, x is equal to 0, y is equal to 2, simply therefore the point 0 2 is the y intersection point, is the y-axis intersection point. You can say y-axis intersection point. Okay, similarly if you put y is equal to 0 here, similarly I can say, and if y is equal to 0, if y is equal to 0, what it will be? If y is equal to 0, it will be 3x plus 2 is equal to 0, right? This part is equal to 0, y equal to 0. If I put it, then here if I take 2 to that side, okay, just carefully do it, minus 2 and x is equal to minus 2 by 3. X is equal to minus 2 by 3. Or finally you can write, therefore the coordinate points are minus 2 by 3, minus 2 by 3 and y is equal to 0. This is the coordinate point where x-axis is cut, where x-axis is cut. Okay, just write that in words, just the way I have wrote it here. For the y-axis you have to write it, this is the point where x-axis is cut and this is the point where y-axis is cut. Okay, so this is the answer for second question. This is the answer for the second question theoretically. And finally what we need to do is draw the graph for p of x. What is p of x? 3x plus 2. We have to draw the graph and then verify all our answers whether it is all correct or not. Let us do that. Okay, now I have plotted the graph here. I plotted the graph by using the coordinate points by putting x is equal to 1. If you put x is equal to 1 here, what will be the 3 into 1? 3 plus 2, that is y is equal to 5. Similarly, if I put 3 randomly, I've taken some points. Okay, so 3 into 3, that is 9 plus 2, that is 11. Similarly, if I put minus 2, okay, now if I put minus 2 here, it will become minus 6 plus 2, and that is, what is the value? 4 minus 6, it is minus 2 only, right? Now similarly if I put 0 here, what will be that? 0, y is equal to 2, and that is the coordinate point that I've already got it here. If x is equal to 0, y will be equal to 2. Okay, now whether I am going to get these points, coordinate points where it cuts the x-axis and y-axis or not. Okay, let us plot the points 1 5. Okay, if it is 1, this is 5. Okay, 1 5. Again I am reminding you that this is the line. For saving the time I have already drawn, but you have to draw it after you mark these coordinate points. Okay, again and again I'm repeating this. 3 11. Okay, so this is 3 and it is 11 here. So here 10 and 11 are the values, so it is 3 11 point. Okay, for minus 2 it is the point minus 4. Okay, minus 2 minus 4. Okay, okay, now I'm sorry, so this is not minus 2, it will be minus 4. Okay, sorry, I've taken 4 here. It is actually 2, right? It is actually 2. So it is 2 minus 6 minus 4. Okay, I'm sorry about that. Okay, now by looking at the plot only, we got to know that this answer is not correct. So that is the reason they told that verify our answers by graphical method also. Okay, you understood this, right? Okay, so for minus 2 it is minus 4. If you just connect all the coordinate points that we have calculated, it will give you a linear line or a straight line. Okay, now we have to verify that whether 0 2 is the y intersection point or not. Okay, for x is equal to 0, where is it cutting the y axis? See, that is at a point 2. Okay, so this is 0 to y axis intersection point, y axis intersection point, as it is verified theoretically also. Now similarly, it is minus 2 by 3. So what is minus 2 by 3? Minus 2 by 3 you can say is 70%, or minus 0.7 or 67 it is exactly. Okay, if you just observe here, it looks like minus 0.7 and y is equal to 0. When y is equal to 0, this is the point, just looks like minus 0.7, which is nearly equal to minus 2 by 3. You understood this? Okay, so theoretically and graphically we have proved that these are the two coordinate points where the both axes are intersected. Okay, so this is the answer for all these three questions. Understood this? Okay. Okay, now let us quickly move to the next problem. Okay, now 11th problem, it is also the similar one, but we don't have to plot the graph, I think, here. Okay, let us read the problem. Let p of x is equal to ax plus b and q of x is equal to cx plus d be two linear polynomials such that p of 0 is equal to 5. So it means that when you put x is equal to 0 here, p of x is equal to 5. It means that is the first input given. Second is the polynomial p of x subtracted by q of x minus q of x cuts the x-axis at 3 0. Okay, okay, listen to me carefully. This is very important problem, because with all these given informations, we are finding out the values of a b c d and putting it here. We will get the values of p of x and q of x, and that is the answer that is required. Finally, see, finally they want find the polynomials p of x and q of x. Okay, there is one more information given for that. Sum of p of x and q of x is equal to 6x plus 4 for all real x. For all the real values of x, this sum of both the polynomials is equal to 6x plus 4 linear polynomial. Okay, to find p of x and q of x, p of x and q of x, we need to find the values of a b. Find the values of a b c and d first. Okay, we need to find out those values. Okay, now how do you find out those values? By given these three informations. Okay, now first one, from 1, you can say from 1 with a given point 1. What is that saying? P of 0. It means that when you put x is equal to 0 in this formula, you are going to get p of x is equal to 5. P of 0 is equal to 5. It means that p of 0, it means like p of 0 is equal to a into 0, a into 0 plus b. Okay, so in place of x, I am putting just 0 here. What is p of 0? They have given it as 5. So what is a into 0 is 0. So therefore b is equal to 5. It means that p of 0, I am putting it as 5 and it is equal to b. So therefore I can say b is equal to 5. See, b is equal to 5. So among the four constants, B value we have already found out by the given one. So now if I substitute B is equal to 5 in this, P of X is equal to AX plus B. Listen to me carefully. Okay, I'm just substituting the value of B because I got it. I can put it and just reduce this linear polynomial AX plus B as, therefore P of X, I can say P of X is equal to AX plus 5 because B value I already got. Understood this? Okay. Okay. Now let us mark this as equation 1. It will be useful for us later. Okay. Now let us consider the third point. Okay, now before I am considering the second point, I am considering the third point in this problem. Okay, listen to me carefully, because there is a linear polynomial directly given, which is sum of these two. Okay, so by which we can find out some more constants. That's why I'm considering the third point. You also have to do the similar way. Okay, so the third point, I can say from 3, the point 3. Okay, P of X plus Q of X is equal to 6X plus 4. Okay, now let me write that first. P of X plus Q of X is equal to 6x plus 4. That is the linear polynomial. Now why I am considering this equality, you will come to know that. Okay, so what is P of X by equation 1? Write this, the modified version of P of X, Ax plus 5. Okay, so it is Ax plus 5. Okay, plus what is Q of X? Cx plus D. Okay, let me write that. Cx plus D is equal to 6x plus 4. Okay, now just group the x terms to the one side and the remaining at the other side. Okay, so it is Ax plus Cx is equal to 5 plus D. Okay, is equal to 6x plus 4. Okay, listen to me carefully, these steps. Okay, from here I'm taking x as common. So what is the bracket? It is a plus c multiplied by x. See, x you multiply to both the terms inside the bracket, it will be ax plus cx. Okay, I'm just taking x outside as a common. Okay, and group this as one more part. Okay, is equal to 6x plus 4. What do you mean by this? Okay, now what do you mean by this equality is, see, this is a plus c into x, it is 6x. Okay, that is coinciding with this left part, and 5 plus d is equal to 4. Understood this? Can I do that equality? Because this equation also looks like a linear polynomial where a plus c is one constant, 5 plus d is another constant, and x is a variable, which actually coincides with 6x plus 4, because that is what is given here, right? You understood this? Okay, now what I will do is, therefore a plus c is equal to 6. I can equate this here. Okay, and then 5 plus d is equal to 4. Okay, so 5 plus d is equal to 4. What do you mean by this? I can take 5 to the right side and get the value of d, right? So b, I got b, I got d. Two values I got. Now therefore I can say d is equal to, or here itself I can say d is equal to 4 minus 5, and that is equal to minus 1. So d is equal to minus 1. The second value also I found out. Okay, now let me mark this a plus c as one of the polynomial that I might require later. So I will have this as equation 2. This is equation 1 and this is equation 2. Now, since I got the value of d is equal to minus 1, can I substitute the value of d in place of d here in the polynomial q of x and write the similar version of q of x similar to equation 1? Okay, let me do that. So therefore, q of x is equal to, initially it is given as cx plus d, but we got the value of d, right? So I can write it as cx minus d, because d value is -1. So I can say it is cx minus d. Okay, let me write it correctly. Cx minus d is 1. Okay, so this I will consider it as equation 3. This. Now let us move and use the information given in point number 2. What is point number 2? P of x minus q of x. Let us use these reduced values of p of x and q of x and subtract one from each other. Okay, and then assume this information later. Okay, okay. Now move to the next and say from point 2. Listen to me carefully. Okay, from point 2, what is that given is p of x minus q of x. Okay, and what are the values of p of x and q of x for us? A plus x, sorry, ax plus 5 is p of x, that is ax plus 5. Okay, and then minus of what is q of x? Q of x is cx minus 1, right? It is cx minus 1. Okay, let us find out the values of this first. Okay, ax plus 5 minus cx, and minus into minus, sorry, that is plus 1. Now again, similar to what we have done previously, let us group the x terms together. That will be ax minus cx, and this is 5 plus 1. This is 5 plus 1, that is 6. Okay, so again what I will do is I will take x outside and it will remain with a minus c into x plus 6. Okay, and what is it is given in second point? Read it carefully. They are saying the polynomial, this whatever polynomial that you get, p of x minus q of x, cuts the x-axis at 3, 0. It means that if you put in that polynomial, listen to me carefully, the polynomial that you get after subtracting this, if you put x is equal to 3 in that, you will get y is equal to 0. What is the polynomial that you got by subtracting this? This is this polynomial. Okay, a minus c into x plus 6 is the polynomial that you got by subtracting q of x minus p of x, and it cuts, they are saying it cuts x-axis, it cuts x-axis at 0.30. Okay, it means so if x is equal to 3, x is equal to 3, y is equal to 0 in the above equation. Correct? In the above equation, that is a minus c into x plus 6. Okay, so let me put x is equal to 3 and equate the whole expression to 0, because that is y is equal to 0, they are saying. Therefore I can say a minus c into 3 plus 6 is equal to 0. Correct? Okay, now let me take 6 to that side and I can say a minus c is equal to, or a minus c 3 times is equal to minus 6. Okay, I just took 3 to the beginning and then taken plus 6 to the right side, it is minus 6. So if you take 3 to the right side, what it will be is a minus c is equal to minus 6 divided by 3, that is minus 2. Okay, so therefore a minus c is equal to minus 2. Okay, let me mark this as equation. What is the equation number we have followed? Okay, 2, 3 we have. Okay, let me mark this as equation 4. Okay, till now you understood this clearly. Okay, now let us we have to still find out the values of a and c, right? So for that we need to make use of two equations. Equation 4, that is a minus c is equal to minus 2. Listen to me carefully. Okay, and we have one more equation with a plus c. Okay, so there are two equations. Equation 2, a plus 6, a plus c is equal to 6. Equation 2, that also involves two constants, a plus c. Okay, and then there is one more equation, that is a minus c is equal to minus 2. So from equation 2 and 4 we can find out the values of a and c. Understood this? Okay, so let me write that. Adding equation 2 and 3, equation 2 and 4, right? What is equation 2? What is equation 2? It is a plus c is equal to 6. Okay, let me write that. A plus c. Okay, and what is left side of equation 4? A minus c. Okay, so plus a minus c, okay, is equal to equation 2's right side is 6, and what is equation 4's right side is minus 2. You're getting it right? Okay, 6 minus 2. It's a simple calculation. So here c will get cancelled and it will be 2a is equal to 6 minus 2, that is 4. Okay, so therefore a is equal to 4 by 2 and a is equal to 2. Okay, now we got the value of a also. Okay, substitute that value of a in equation 4, you will get the value of c. Okay, equation 4 or 2, any equation you can put it. Okay, now let me substitute that in equation 2 only, because it will be easy here, because c I have at the left side, take a to the right side. Okay, so from 2 I will write from equation 2. Okay, therefore from equation 2, I can say c is equal to 6 was on the right side and I'm taking minus a, 6 minus a. Okay, so therefore c is equal to 6 minus a is 2, therefore c is equal to 6 minus 2, that is 4. Okay, now we found out the values of a, b, c, d. All the four values we have found out, and we have the equations p of x, that is equation 1, and q of x, that is equation 3. Okay, we have already substituted the values of b and d in these two equations. We are now left with values a and value c to be put into this. Okay, and now we have found out that values also. Now listen to me carefully. We have to make use of equation 1 and 3. Okay, let me write that. So from equation 1, what was equation 1? Equation 1 was about p of x. Okay, it is p of x is equal to ax plus 3, right? It was ax plus 3, correct? Ax plus 5 it is. The value of b is 5. Value of b is 5, and now I can substitute a value as 2. Therefore p of x is equal to 2x, correct? 2x plus 5. This is one answer. Okay, and from equation 3 it is cx minus 1. Okay, from equation 3, that is q of x is equal to cx minus 1. Substitute the value of c is equal to 4. This will be q of x is equal to 4x minus 1. So these are the two polynomials that were initially required in this problem. Okay, now let us quickly move to the next problem. Okay.